Okay, everyone. Thanks for having me here. I'm Daniela. I'm going to show you how to build Pac-Man from scratch. First, just to give you a bit of context about who I am. I'm Brazilian. I'm living in London since February, so I have been here for like 4 months and a half. And some fun facts: I used to be a runner, doing half marathons. I got injured. Maybe I'll come back one day. I love cats. I work in IT since 2004-ish because I like to change my career a lot. So I did some weird stuff, like going to medical school in the middle of this. But yeah, I'm a software engineer and I work at the data infrastructure team at GoCardless. And so some may say I'm a data engineer, if that's a thing. And GoCardless is a fintech that we are trying to improve like how to make recurring payments. So if you're interested, here's our website. But yeah, today I came here to talk about Pac-Man. This unfortunately is not a thing we do at GoCardless, but this, for those who doesn't know what's Pac-Man, this is about this game. And while most of you, I don't know, may know this game by this version, I got to know this game by this version. This is the Atari 2600 version, and it's kind of takes me back a while. And probably the reason I'm here today, not today to do this talk, but today as a software engineer, as someone that is in this industry, is because of this game. So it kind of was really powerful. During my childhood, I used to play, and I used to think, oh my God, this is so magical. And that square in the middle was really the thing to aim for. Oh my God, so much points. So anyway, I did want to know how to make those things, so that's why I became a software engineer. But I'm not here to talk just about the game. Actually, I like to call this Pac-Go, Pac-Man in Go. You need to have Go when you name something in Go. It's about a language tutorial. So, and here I'd like to make a disclaimer. This talk is, I think if you're a beginner in Go, it will be very helpful. And if you're an expert in Go, maybe you'll take some out of this. But it's really about like a tool to teach other people how to learn Go in a fun way. I helped to create this concept back in 2017 with a team back in Brazil. And it started as a Women Who Go workshop. We wanted to teach girls that didn't know anything about like computer science, how to like build something interesting, how to make them interesting in the field. And we thought, oh my God, like building an API, I don't know, that doesn't look that interesting. But a game is accessible, and with emojis, yeah, that's a great idea. But the rest, I promise I'm almost finishing my slides, and the rest of the talk will be only code. But before that, I need to cover two pieces of theory. One is about terminal modes. So usually when we are going to use the terminal as the screen for the game. And usually when you launch a terminal, you get into what's called a cooked mode. And the cooked mode basically is a mode in which the terminal captures every keystroke you do and pre-processes it before sending to the application. For instance, that's how it processes like Control-C, that you know you need to terminate that application. So, okay, it does pre-processing and then sends the signal. It also pre-processes arrow keys and some extended keystrokes. On the other end, there's the raw mode that kind of passes everything as is. And as you can imagine, the C-break mode is like the middle term, and where it pre-processes some signals and some it doesn't. And we are aiming to initialize that mode because we want to capture the arrow keys, but preserve other signals like Control-C. We are also using some terminal magic, as I like to call, that are NC escape sequences. And those sequences are like magical strings that you print to the terminal to have like side effects. And for instance, you want to change the cursor position. That's very important for the animation part of the game. You want to clear the terminal. and you want to change the background color. So this is how escape sequence look like. You have like the byte code for ask, the ask key, x1b in that case. You have the square bracket, the left square bracket, and the n number of bytes. You can read more about this in the Wikipedia. And okay, let's go to work. Now it's just code. Few seconds if you want to take the picture. This will take you to the GitHub repo, and let's go for it. So the first thing, this is a very express version of the tutorial, so I'm not covering all the bases here, but you can see the whole text in the GitHub repo. But the first thing you'll see in regards to code is like this bare bones skeleton of the game. It has, let's try to make this a bit larger. So you have this like a minimal Go program. You have a package name, you have an importer font, and these comments are placeholders for the code that's going to get into the game. And every game, like the classical way of doing this is having like an infinite loop that you can actually terminate if the player dies or you decide to quit. And in this case, this is just like the bare bones for a hello world type of program with a break. And just for the sake of running it, we have this Pac-Go, hello Pac-Go, that's the code. I know it's, let's try to, just hello world, nothing special. Then you have the tutorial structured in steps where we're going to start filling those spaces. So the first thing we are going to do is load the maze. And if you are teaching this or maybe learning, it's very interesting to load this kind of pattern of function calling. Thank God this is going to stay with us. I don't know if you have heard that the try thing didn't pass. Thank you. So this is how we handle our handling Go. You usually a function, the last parameter is an error, and you try it. So okay. You also have the opportunity to talk about the defer function. You place something to be called in the call stack at the end of the current block. So basically, the idea here is we're opening a text file, reading each line of it, and we're appending to a maze slice of string. That's going to be our representation of the maze for the entire program. We also have like a print screen function that at this moment just like runs through every line of the maze and just print it. And we'll start filling the gaps in the main function. So we have our loading resource, we're loading the maze, we're printing the screen, and just temporary to break the infinite loop, we have a break. And this is step 1. So, okay, for now we just have like a green screen in black with some ASCII codes. That's just for the nostalgic feeling of it. But the representation of the board is like the hash signs are the walls, the dots are the dots in the game, G's are the ghosts, P is the player, there's some X there that are the power-up pills. Okay, let's get this a bit more complicated. So next step, we're going to start handling input. So we're also adding some helper functions to clear the screen and prepare things for animation. So now we are using those like escape sequence, like magic escape sequence to clear the screen, move the cursor. Now print screen calls clear screen each time, so we have delusion of animation. And we have now this read input function that reads from the standard input. In this case, we're just checking for 1 byte and checking if that's the escape key, and returns like a string called ask. And the idea is just to exit gracefully. Why? Because we are initializing the C-break mode and we want to restore it afterwards. If you just do a Ctrl-C, you lose that cleanup code, so that's not good. Since this is a tutorial, I'm using things that kind of just for fun. I didn't need to use this. But in this case, for instance, to initialize the C-break mode, I'm using a init function. And that has a special meaning for Go. Like init function runs before main. And it's originally meant to be used for package initialization code. In this case, I'm just using for the sake of using it and like creating awareness about it. So my main function now looks like I have this defer cleanup because init is implicitly called for me. And in the main loop, I have that read input that for now I just process the escape key. And now I can get rid of that that break. And I'm just checking for that kind of input. Kind of in terms of the step, it doesn't look that different. But trust me, this I can press any key here, nothing happens, and only will quit if I press the escape key. But kind of under the hood, it's kind of animating things because I'm calling clear and I'm calling print screen again. Things will get more interesting in the next step, step 3, because now we are adding the player. So the player is just a struct with row and co properties. And we have this global variable player. And the thing is, when we are loading the maze, now we're first loading everything, and we're looking for in the maze where the P is located with a switch statement. And then we construct the OR player at the given row and co. And besides that, I've also changed the print screen function. Now instead of just printing each line, we need to be a bit smarter than that. And I'm printing here only the walls for now. And afterwards, I print the player at the given position. And you may notice that I have like this standard case I have this case for the walls, and I have the standard case that's default that just print a space, and I have nothing in between. That's because we don't have that fall-through behavior from other languages. The default case, the default statement here is kind of, we have like an implicit break in Go. And if you want really to fall through to the next case, you need to explicitly say fall through. Okay. Other than that, we also need to change the read input function. Now we're processing arrow keys. And arrow keys are like 3 bytes long. They start with the escape key. They have this left square bracket, and also the third character is either A, B, C, and D. That we are just converting to like the strings represent these coordinates. One interesting thing is that I'm reading from standard input to a buffer that's 100 bytes long, but I'm not interested in reading 100 bytes. Why is that long, that buffer? Because this is a game. It's not important to be precise, like processing every keystroke, but you need to process them as fast as possible. So if the person holds like the left key and it emits like 100 keystrokes, I don't want to process 100 keystrokes to the left. I just want to process the latest one. So that's why we're just skipping everything, just processing the first position of the buffer. Another thing we have here is this make move function that basically has all those boundary checks to make sure we are not going off limits of the maze, and also creates that nice effect of Pac Man that if you leave the screen from one end, you appear on the other. And here I use some, like, there are some people that don't like this, but just for awareness, I'm using name return parameters. You can actually declare the return like this, and then you assign the value you want to return in the middle of the function. And this function works by calculating a new position. It checks if it is a wall. In that case, just restores the old position. So it kind of like, it's a bit optimistic, and then, okay, oh, you hit a wall, so I roll back. So that's how it works. And that's, since I'm using named return parameters, I can use a blank return statement. Final piece of the puzzle is this move player function that takes a direction and just like calculates the new move. If the direction leads to a wall, it's just like do nothing. And the game loop changes are pretty simple. I just have this comment like process movement and add move player with the given input from the previous step. So looking at all this together, now I have the P is moving and I can go from one end to the other, and it works fine. I can go through walls. Everything is nice. Let's add a bit more stuff now. Things are going to go faster. Now I have to implement the ghosts, and the ghosts are basically like the player. They are structured a row and a column, but now I'm using a slice of pointers to ghosts. Why pointers? Because I need to update their values, and this will be, I want to update their positions and using a range statement. It's kind of, if I didn't use the pointers, it was also possible to make the code a bit more complicated than it needed to be. And also, it's a good opportunity to talk about pointers if you're like doing this tutorial in a workshop kind of thing. For the load maze, now I had the case for the player, now I have the case for the ghosts, and I'm just appending them to this slice of ghosts. And same for the print function. I printed the player, and now I'm ranging through all the ghosts and moving the cursor and printing them for now just as a G. And we also need to make the ghost move. We have this draw direction function. It just draws a random number from 0 to 3 and assigns like a position to it. And the move ghost function takes for each ghost, tries to draw direction and make a movement. If I hit a wall, it's the same thing, just fall back to the old position. And the main function, I just need to add this move ghosts thing, and let's see how that works. So step 4, here are the ghosts. Oh, they are not moving. Why is that? Okay, but then when I move the player, they move. And this bug is kind of because during my main loop, I'm actually blocking, waiting for the player input. We are going to solve this in one of the next steps, but first let's make this like a complete game. And we're missing two important things. For this to be a game, a proper game, we need game-winning conditions and game-over conditions. So we're first dealing with that. For game-winning conditions, we're reintroducing the dots to the maze. And we have this dots counter, we have a score and a number of lives. And the idea is, if the player eats all the dots, it wins. Or if a ghost collides with it, the player will die and the game is over. This lives thing is an integer, but I'm just using a kind of like a Boolean, but the change to support like multiple lives shouldn't be that difficult. Here's the case for fall through. If I have like a wall or a dot, I just print it. The default I print space. The rest of this function keeps the same. And there's this import part that now I need to keep track of the score. And so when I move the player, if I find a dot in the new player position, I'll just decrement the number of total dots, increase the score. And since strings in Go are immutable, I'm kind of doing some slicing magic here to remove that dot from the string using like I'm slicing that string until the position previous to that dot, adding a space, and then I'm adding the rest of the string, and I'm replacing the content in the maze. So it's really important to bring this kind of awareness that's how strings works in Go. And other than that, I also have now the game over conditions here. I'm processing collisions. It's just a matter of checking if the player position is the same of any of those ghosts, and also checking if lives is 0 or the num dot is 0, then the game is over. So let's see how that works. So that's step 5. So of course I removed all the dots because I don't want to stay here forever. This is the game win condition. We have a bug. I haven't rendered the last frame of it, but that's good enough for now. We're going to fix that in a second. And this is the game over. I hit some random ghost there. Okay, so we have a problem to solve. That's not a very interesting game if I'm blocking on input. And if only Go had some kind of structure that will help us make things in parallel. Yeah, we just saw that, right? So we're changing the code that processes the input to do it asynchronously. And we're using both channels and Go routines in that case. So we're spawning a Go routine that waits for the keystroke, and it will take that input and write it to a channel. And now in the main loop, we just need to read that channel and for the kind of input we're expecting. But it can't be a blocking read. We need to make sure it doesn't block. So we have this empty default clause that makes sure that if nothing is ready in this channel, it just runs through the default. You could have like here, like 1,000 channels. It will run the first that's ready. And then in this case, we're just, okay, we just have one channel. If it's ready, we're going to run. If it's not, just skips. Move the goals, process the collision. But now we need to make sure that this doesn't run too fast that the player can't keep up. So we're introducing this delay in the loop. So I'm waiting for 200 milliseconds, so this game runs at impressing 5 frames per second. So, and let's see how that works. And ta-da, the goals are moving independently of me. I kind of fixed that rendering bug. And you're probably tired of seeing this black and green screen by now. But I promised the emojis, I'm just getting there. So the emoji thing works by giving, I have this config.json file that creates kind of a mapping for each element in the game. So the player is this happy face, the ghosts are the ghosts. You may notice that the wall is like 2 spaces instead of 1. And I also have this use emoji flag. That's because since we just saw Go use UTF-8, some character codes are 2 bytes long. So we're making this to make sure that if I use an emoji that's 2 bytes long, I'm having everything aligned and perfectly aligned in the rendering. And handling JSON in the code is really easy. It's just a matter of defining a struct that receives that. And we use these JSON tags to map to which property the JSON reader needs to load the data. We have this global that's config struct. And this is the load config code. It just opens the config file, invokes a decoder, and decodes to that struct. The rest of the code is about, I have to change the move cursor function to actually take in account if I'm using emojis. I'm going to do some displacement to take account for the 2 bytes thing. And other than that, I'm just like replacing the hard-coded letters with their configuration files. And for the walls, I did some kind of magic here. I'm just changing the background color to blue, printing the wall, and then changing back. This is a reset code in ANSI. And also, I added some like that animation here somewhere that I'm just printing like a that emoji to be precise. And let's see how that works. And as promised, emojis. Nice. Thank you. I'm not playing this until winning, but the idea is to continue evolving this tutorial, and this part of the code I'm not showing, but you may see it's not challenging, like the ghost moving like that way. So I kind of used all those years studying for coding interviews, and I implemented an A-star path finding algorithm. So now the ghost chases the player, and this is called the step X, because not ready for a tutorial, but they kind of, you see oh my God, I'm dead. So you may try, look at the implementation. I'm using this step X as a sandbox for the next things to come, and which gets me to the final part of this presentation, that the idea is to work with other features of the Go language. I already have written the step 8, is about flags. but also we are missing testing, interface, receiver methods. We actually need to improve the game, maybe adding sound someday, I don't know. But this is an open source project and I didn't do this for myself. It's a tutorial. It's meant for the community to use to learn Go. So please, if you're interested, submit PRs. I promise I'm nice reviewing them. And that's it. That's what I had to show you today. So, thank you.
There's got to be some questions. There's got to be some questions. You happy to take questions?
Yeah. Does anyone?
I'm going to bring out the magic mic. Here we go.
I'm coming from Node.js background and try to switch to Go. I see that you use JSON. How easy is to work with dynamic data? Because Node.js is dynamic, it's interpreted, and you can extend any data or modify it. And how easy is to modify data in Golang in JSON structure, and how performant it is?
Could you repeat the question?
Okay, he's asking about how easy it is to process JSON data in Go, and also especially dynamic structures. And I had some experience actually at the GoCardless with writing some code that does just that. And sometimes you need to deal with interfaces, but that's handled pretty nicely by the standard library. So yeah, I think it's pretty performatic, and I didn't find anything that was particularly difficult. Even with recursive structures, you just need to define the types, I had a situation where, like for instance, I was decoding Avro. I don't know if you have seen that standard, but for instance, it has the type keyword can be either an object, can be a string, or can be a list. And to handle those kind of things, you can extend the standard library by defining your custom unmarshalling function. So you are completely covered. You can do everything that you do in Node.js.
Thank you.
Next question. Sure, we've got need one from the back. Someone over the back posturing. Is that a question? No, you just not between yourselves. That's all right. Question? Share with the group.
We were discussing, does this actually work as an introduction tutorial to programming for little kids? So,
Oh.
you're using the ANSI escape code sequences, you're using like super low-level stuff that for most people that understand the basics, it's understandable. But how do you manage to actually use this as a tool to teach programming to kids?
Okay, so just to clarify, he's asking how to use this tutorial to teach to kids. And just to clarify, the tutorial was not designed for kids because you definitely, and this has been an issue, I think, in the Go community. A lot of people are trying to fix this because Go is not an easy language for to be your first language, because there's all these Unix-like things that you need to get used to. So the tutorial was designed to for people starting in the field. So they must have some kind of previous knowledge of they can handle themselves in the terminal, for instance. But some people are trying with teenagers. I've known, because the thing is, since we are using emojis, it kind of gives them something to connect with. That maybe they won't connect with Pac Man. They probably have no idea what Pac Man is, but they know what is an emoji. So that gives some kind of emotional connection. But probably in those kind of scenarios, we need to introduce the emojis much earlier in the process. But I don't know. I don't have any experience holding this kind of workshop with teenagers or kids. I think it's really useful for an introductory tutorial for the language itself, but for someone that already has some the basic knowledge of how a programming language works.
So to add to that, I'd say like we can always add abstractions. We don't have to expose all that low-level stuff to kids if we're trying to teach kids programming. We use abstractions to teach kids all the time, like about Santa and how presents work, and then they grow up and realize that's not really how it works and get really sad.
Yeah.
Abstractions, right?
Adding to that, the first version of the tutorial, we kind of had this utils package that did some magical stuff, so we didn't expose all that complexity. But I thought, like, for this kind of audience and for my purpose for this version of the tutorial, I want to like explain how everything works.
Brilliant. Oh, last question.
It's not really a question, it's an observation. This is an example of a bounded problem where you know exactly what you want to do. Games are very, very like that and extremely useful because there's lots of different ways of working out what the solution is and you explore the language. Most examples that you find in textbooks are horrible. They're usually based around mathematics, functional programming. A number of times I've seen a set of the rest of these, an example, that sort of thing. Really annoying. This is good. Yeah.
Thank you.